Hey guys, welcome to the worked answers for the 2017 Day 1 MCAT exam paper. Let's get into it. So, question 1. The distance d centimeters travelled by an object is given by this equation: d equals ut plus 3t squared. If u equals 3 and t equals 5, calculate the distance that the object has travelled. Okay, so it's a classic substitution question to get us started. We've got this equation, d equals ut plus 3t squared, and we've been given u equals 3, t equals 5, so wherever we see u and t in our equation, we're going to be substituting 3 and 5 in. So d equals u is 3, t is 5, and plus 3, 5 squared. Okay, so 3 times 5 is 15, and we've got plus 3, now 5 squared is 25. We can say 15 plus 3 times 25 is 75. So our distance travelled is 15 plus 75, and that is 90. Okay, correct solution here, no alternative. D equals 90 will get you the achieved grade. Moving on to question 1b now. We've got this, we've been asked to solve this quadratic: 2x squared minus 3x minus 9 equals 0. So this quadratic, there's really two types of quadratics in the MCAT. You've got quadratics where a is greater than 1 and where a is 1. So what I mean by that is a quadratic is written in the form ax squared plus bx plus c, and in this case a is greater than 1. It's 2, right? Meaning, to solve this quadratic, we first go a times c, so 2 times negative 9, and that equals negative 18. Okay, and so we're looking for two numbers that multiply to negative 18, and two numbers that add to the b term, which is negative 3. And those two numbers are minus 6 and positive 3. So we're now going to split the b term. So we're going to say 2x squared minus 6x plus 3x minus 9, and that equals 0. So we haven't actually changed the equation, only rewritten it. You can see this minus 3x is just written in the form minus 6x plus 3x here. Okay? Now we're going to split the whole quadratic now. We're going to chuck our line through the middle, and we're going to factorize the left-hand side. So a common factor is 2x, and we've got x minus 3 in the brackets, and factorizing the right-hand side, we've got positive 3 and x minus 3 also in the brackets. And you know you're on the right track when your two brackets are the same. So now we can say 2x plus 3 is a bracket, and x minus 3 is a bracket, and that equals 0. Therefore, x equals minus 3 over 2, or negative 1.5, or positive 3. Okay? And these two solutions, negative 3 over 2 or 3, gets you the merit grade here. You're achieved factorizing the quadratic. So basically anywhere before your final answers. Factorising, maybe here, probably closer to here, gets you the achieved. Okay, let's keep going. Question 2C now. 1C. If 6x minus y equals 21 and minus x plus 6y equals 14, what is the value of x minus y? So we've got two equations here. 6x minus y equals 21 and minus x plus 6y equals 14. And they've asked us what is the value of x minus y. Obviously we don't know what the variable x is and we don't know what y is. So we have to use these two equations and perform simultaneous equations, solve our variables, and then we can do x minus y. So obviously you can do the substitution method or you can do the elimination method. Either would work here. I'm going to use the substitution method. So let's say let's take this top equation and say y equals 6x minus 21. Okay, I've just rearranged there to make y the subject. And so now we can say minus x plus 6, and instead of saying y, inside brackets you go 6x minus 21, so we're substituting in y, equals 14. Okay, expanding the brackets, you've got 36x minus, now 6 times negative 21 is negative 126 equals to 14. Collecting like terms, you've got 35x, and let's move our negative 126 to the right hand side. So it becomes 14 plus 126, and that would be 140. And so solving for x, no calculators obviously in the MCAT. This particular equation isn't too hard though. 140 over 35, well 35, 70, 105, 140. So x equals 4. Okay, we've got our x, we need to find y. We can take y equals 6x minus 21 and say y equals 6 times 4 minus 21. Therefore y equals 24 minus 21. And so y equals 3. Okay, we've got our value for x and we've got our value for y. Now we can go ahead and solve x minus y. Let's do it down here. So x minus y equals 4 minus 3, and that equals 1. Okay. X equals 1 here gets you the excellence grade. For your merit, solving for one variable, so either x minus 4 or y minus 3 gets you the merit. And you're achieved correct combining of equations in one variable. So here you can get an achieved. Okay, let's keep going. Question 1D now. We solve 9 times 3 to the power of x minus 4 is greater than 87 when x is a whole number. So we've got this equation y times, or this inequality rather, 3 to the power of x minus 4 is greater than 87. And I say it every time it comes up, this is a classic MCAT question. It helps to know your powers of numbers in the MCAT, so powers of 2, 3, 4, 5, 6 even. Okay, and the powers of 3 here, if we just list them down, okay, you've got 1, 9, 27, and 81. And so we're going to rewrite. You could divide 87 by 9, but obviously no calculators in the MCAT, and that's not really what they're asking us to do. We're going to rewrite 9 as 3 to the power of 2. So 3 to the power of 2 times 3 to the power of x minus 4 is greater than, and instead of using 87, we're going to say, notice that 3 to the power of 4 is 81, so we're going to say we're going to use 3 to the power of 4 in our equation. Okay, because if our left side is greater than the right-hand side, when x is a whole number, then that value for x will be greater than 3 to the power of 4, okay? So, let's say 3, we're going to combine left-hand side, we're going to say we're multiplying two numbers with the same base, so using our power rules, we're going to be adding the indices, so 2 plus x minus 4, so it becomes 3 to the power of x minus 2, and it's greater than 3 to the power of 4. And another one of our power rules, we know when the bases are the same, we can basically equate our powers. We can cancel our base, so we cancel the 3's, and we say x minus 2 is greater than 4. Okay, rearranging, x is greater than 6 here. Okay, I hope that makes sense. The 87 tends to throw people off because you're not working with exact powers of 3, but that's exactly why you also have the inequalities in the question there. So x is greater than 6. You could also say, and the marking schedule mentions it, x is greater than or equal to 7. So that's what I was getting at before. Okay, so correct solution showing algebraic working gets you the excellence here. Your merit comes from 2 of the procedures for achieved. So for achieved, expressing an index form with the indices for the left-hand side combined. So here you'd get an achieved. And your merit, equating of indices. So here is your merit. Okay, let's keep going. So question 1E now. Jane thinks of a number k. When Jane's number is cubed, the answer is m times k. When Jane's number is squared, it is n more than k plus 5. Give an expression for n in terms of m only. Okay, so we've got basically 3 sets of information here. It's important to just work through it methodically. Obviously, we're going to be forming some equations. And let's just start from the top. So we've got this number k. Okay. when Jane's number is cubed, so k cubed, the answer is m times k, so let's say mk. When Jane's number is squared, the answer is n more than k plus 5. So that looks like you've got k plus 5, and the answer is n more, so plus n. Okay, and again we want to give an expression for n in terms of m only. So they're asking us to basically eliminate k completely from this equation. Now how do we go about doing this? Well, let's first say, we could say, using this equation, k cubed equals mk, we could divide by k on both sides and say k squared equals m. Okay, and even taking it a step further, we could say k equals the square root of m, because we're square rooting on both sides now. Okay, so here are two more equations that might help us. Now looking at k squared equals k plus 5 plus n, and keeping in mind that we just said we're trying to eliminate k, well, we now have values for k squared and k. So k squared, we can just say m equals, and instead of k we say root m plus 5 plus n. Now we're not quite done. We have to write the expression for n in terms of m. So rearranging, we can say n equals m minus root m minus 5. Basically, we've taken the root m and the 5 to the left-hand side. Okay? And believe it or not, this, guys, is the correct solution, and for this you get an excellence. Your merit, you've written the original equations, you've done a consistent expression without k squared, and you've written k as equaling root m. Let's just say this is your merit here. Achieved. They mentioned k squared equals m. So somewhere up here, you'd pick up an achieved. Okay, let's keep going. Question 2 now. We've been given this equation h equals 9 minus 4x squared. Give the equation 4x in terms of h. Okay, so all they're asking us to do is rearrange 4x. So we're making, okay, we've got our equation h equals 9 minus 4x squared, and we're making x the subject, so it'll look like x equals whatever. So the first thing we can do is take our 9 to the left hand side, so we can say h minus 9 equals minus 4x squared, remembering we're doing the opposite of BEDMAS. Now we divide by negative 4 on both sides, so h minus 9 over negative 4 equals x squared. And we've got x squared, but they're asking us for x. So the opposite of squaring something is square rooting, so we're going to say x equals the square root of h minus 9 over minus 4. Okay? And this gets you the achieved grade. The marking schedule mentions plus or minus. Okay, it's a fair point, plus or minus here, because you're square rooting something. You'd still get the achieved even if you forgot that though. Okay. Question 2b now. I've been asked to simplify this fraction, x squared minus 5x plus 4 over 5x squared minus 20x. Obviously, the first thing we're going to do is write out our fraction. And straight away we can see that we're probably going to be factorising here. When in doubt, factorise in the MCAT. So look in the numerator. We can say x minus 4 and x minus 1 is the factorisation here, and that's over 5x is a common factor, and x minus 4. Okay, and yes, we can cancel here. We've got x minus 4 in brackets both in the numerator and denominator, so they cancel, and we're left with x minus 1 over 5x, and that's as far as we need to go here. So this gets you the merit grade. Achieved one of factorising the numerator or factorising the denominator, so either or gets you the achieved here. Okay, question 2c now. An L-shaped model is to be made from the following sketch. And we've got our model. It's got side lengths of 2, 12x plus 1, 4x minus 2, and 2x plus 3. We're missing side lengths, you'll notice, of this side length we're missing, and this side length. Okay, we've got to keep that in mind. The question asks us, what is the perimeter of the model in terms of x? So we know the perimeter is sum of the sides of a shape. Okay, so we're just going to go around and substitute in our side lengths. So starting from the 2 and working clockwise, we can say 2 plus, now what is our red arrow? What is that value? Well, if we split up our shape this way, so we've got obviously this long rectangle, and we've got this rectangle here, okay? That's how we're going to split up our shape. It's the only way to find our unknown side lengths. So it's 2 plus, it's going to be 12x plus 1 minus 12x plus 1 minus, this is in the brackets, 2x plus 3. And that's all in brackets actually. Okay, 4x plus 2 has been given to us. That's 4x minus 2 rather. Plus 2x plus 3 plus, now our bottom red line, the one that goes horizontal, that will be 2 plus 4x minus 2. Okay. I hope you see where I'm coming from there. I'm adding this and this to find this measurement. Okay, so 2 plus 4x minus 2, and we'll use brackets just to demonstrate that. And finishing us off, 12x plus 1. So, just conscious of the amount of room we've got here, let's collect like terms and expand brackets at the same time. So, we've got 2 plus, and when I say collect like terms, I mean, so we've got our single digits, and we've got our, obviously our terms with x in them, okay? So, working with the single digits, the ones highlighted blue, we've got 2 plus 1 is 3, minus 3 is 0, minus 2 is minus 2, plus 3 is 1, 3, 1, and 2. So it'll be 2 and plus. Now looking at our terms with x in them, so the green highlighted terms, we've got 12x minus 2x, so that's 10x, plus 4 is 14x, plus 2, 16, plus 4 is 20, and plus 12 is 32. So that gives us 32x. And with that, we've found our perimeter. 2 plus 32x, or the marking schedule says 32x plus 2. For that, you get an excellence grade here. Okay, your merit correctly found the perimeter, but has gone on to solve for p equals 0. So you might have said like p equals 0, therefore 2 plus 32 equals 0, 32x equals 0, and you might have solved for x there. Okay. It's a mistake that is understandable. That would get you a merit. But otherwise your merit is, well, we've only really given ourselves 2 steps of working, and the second is the excellence. So let's just say our first is, if we were doing multiple steps of working, so if we took the time to expand the brackets and then collect like terms, that would probably be your merit. And just setting up the equation would be your achieved. Okay, let's keep going. Question, what is it? C2 now. The area of the model is 92 centimeters. What is the value of x? So we need to set up an equation for the area. So we know area of a 4-sided shape is base times height. So the area for our, the total area, that is, for our L shape is, and we go back to, we look at the way we split our shape earlier, so we had that and we had that. this is where that comes in handy, right? So we can say the area of this shape is the area of the vertical sort of skinnier rectangle plus the area of the horizontal rectangle. Okay, and that equals 92, right? Because the area of the model is 92. That's something they've given to us, and we're trying to find the value of x. So substituting in our equations, looking at our vertical, we'll have 2 and 12x plus 1 as the side lengths. And for our bottom rectangle, we will have 4x minus 2 and 2x plus 3 for the side lengths. 4x minus 2 and 2x plus 3. Okay, and they equal 92. So, expanding our brackets, we've got 24x, because 2 times 12x is 24x, plus 2 times 1, of course, and plus, and obviously when I talk about expanding brackets, that's using the FOIL method, so first, outer, inner, last. Okay, we've got 8x squared plus 12x minus 4x is 8x and minus 6, and that equals 92. Collecting like terms, just cleaning this up a little bit, we can say 8x squared plus 32x, because 24 plus 8 is 32, minus, we've got our minus 6. Let's bring the 92 to the left-hand side to get it in quadratic form, so equaling 0. We can say minus 6 minus 92 is... have I made a mistake here? Just checking the answers. So I missed this. I missed this 2 here. The 2 and the 6 is negative 4 minus 92. So we've got minus 96. And it equals to 0. Okay. Always look for a common factor. Straight away we can take out 8 as a common factor. Uh, 96 over 8 is 12. And that's making this quadratic a hell of a lot easier. Divide by 8 on both sides, as 8 just cancels. And we're left with x squared plus 4x minus 12. So we've got, factorizing this, minus, positive 6 rather, and minus 2, and it equals to 0. So x equals minus 6 or positive 2. Obviously, we're working with a shape, so we've got lengths, and so x in this case cannot be negative. Can't be negative, meaning minus 6 is not a valid answer, so the only answer is x equals to 2. Okay, and correct solution here gets you the excellence grade. Your merit. expanding, simplifying, solving the equation, solving the quadratic, so consistent solving. So expanding, simplifying will be your merit, so here, and your achieved, setting up the equation for the area is here. So as early as this step gets you the achieved. Sweet. Moving on to question 2D now. Leo is laying square concrete tiles for his deck. He starts with laying them down to form a square pattern, but his friend thinks it would be better if they laid out to form a rectangle. He changes his layout to make the length of the deck 6 tiles longer and the width of the deck 4 tiles shorter. He finds he needs 2 extra tiles to complete the rectangular pattern. How many tiles did he have to start with? Okay, so a lot of information there. It's good to draw pictures. In this case, he had a square. Okay, and then he went to a rectangle. So for the square, obviously, properties of a square, all 4 sides are the same length. So let's say x is number of tiles he started with. So we had x, and the area, if it comes to that, was x squared. Now for the rectangle, he changes his layout to make the length of the deck 6 tiles longer and the width 4 tiles shorter. So the length is x plus 6 and the width x minus 4. Okay, and now what do we do with this information? Well, let's work with areas. Let's say, because obviously the area is total number of tiles, right? If you split this deck up, then that area would help you find the total number of tiles. Okay, so let's say x plus 6, remembering that area is based on side, x plus 6 and x minus 4 equals, let's equate our equations, and we'll say x squared. And remembering this last bit of information, he finds he needs 2 extra tiles to complete the rectangular pattern. So let's say plus 2 here. Because with the rectangle he's missing 2, and if we're equating before and after, that means the x squared has plus 2 on it. Okay, so expanding these brackets, we're going to say x squared minus 4x plus 6x is plus 2x minus 24 equals x squared plus 2. Our x squareds cancel out. Rearranging for x, we can say 2x, and we'll bring the 24 to the right hand side. 2 plus 24 is 26. Okay, meaning x equals 13. Now, is this what we're trying to find? I said x was tiles that we started with. That's not true. X is is tiles, but that's one tile, right? Well, that's like... so just to clear this up, we said x was actually a side length, so third time lucky, it's not the total number of tiles, it's not one tile, it's a side length for our original square pattern. So if we've got 13 tiles on the base and 13 tiles for the length, number of tiles he had to start with will be the area of that square, which is x squared, which is obviously 13 squared, and that equals 169. Okay, I hope that made some sort of sense. Honestly, if I was looking at that equation and doing it in the test, I would possibly struggle. I've got the help of the marking schedule here with me. Anyways, moving on to question 3. Grades for that. Excellence grade here. Correct solution, 169 gets you excellence. Your merit sets up the equation and simplifies, generating a linear equation. So merit here. Setting up the equation gets you the achieved. Okay. Question 3. The area of a rectangle can be represented by 3x squared plus 2x minus 40. State the length and width of this rectangle in terms of x. So we've got our rectangle. The area is 3x squared plus 2x minus 40. And we want length and width. The previous question helps us to understand what we're doing. We're just doing the reverse of that. We're going to factorize, and that gives us our length and width. So 3x squared plus 2x minus 40. Again, it's one of these quadratics with the a is greater than 1. So that means we're going to have to multiply a and c. So 3 times negative 40 is negative 120. Meaning we're looking for two numbers that multiply to negative 120 and add to the b term, which is 2. And they are positive 12 and minus 10. So 3x squared plus 12x minus 10x minus 40. This is what we did, I think back in question 1. Putting our line through the middle. Factorising left hand side, we've got 3x and x plus 4. Factorising the right hand side, this is x in here, and x plus 4. Okay, so we've got 3x minus 10 and x plus 4, and they are, these two sets of brackets are our length and width in this situation. Okay, achieved grade for this one. Question A2, given that this quadratic expression represents the area of a rectangle, what would be possible values of x? Well, let's say our two slide lengths, 3x minus 10 and x plus 4 equaled 0. meaning we could solve for x. We would have x equals 10 over 3 and minus 4. Obviously, and again this is similar to a previous question, we're working with actual length, so x cannot be negative, it must be positive, because our area is well, it's just common sense, isn't it? Lengths and area are positive, meaning x can't equal negative 4, so x equals 10 over 3. And this gets you, we should have to mention that x must be negative. Okay. So, merit grade for this one. Achieved. Solving from the previous question, solved giving 2 solutions, so I think the difference between the achieved and merit here is probably your minus 4. So 2 solutions will get you the achieved, just 10 over 3, giving that as the solution would get you the merit. Okay, question 3b. 2 to the power of 3x plus 4 equals, is greater than 2 to the power of x squared. So in this situation, we're going to go ahead and straight away employ our base and power rules. We've got bases that they don't equal each other, but they may as well do. We've got a greater than symbol in there. Still, we're going to cancel the bases and just work with our indices. So we can say, because the 2's are the same, 3x plus 4 must also be greater than x squared. Okay, rearranging, we can see a quadratic starting to form. I'm going to keep x squared on the right hand side because I like having positive x squared. And you've got minus 3x minus 4. Okay, factorizing. Our 2 numbers are positive 1 and minus 4, so x plus 1 and x minus 4, and that's less than 0. Now let's assume for a moment that it equaled 0. We can say our values for x are x equals minus 1 and 4, but that's not the final answer. We have to take into account this inequality here. And let's draw it, okay? It's a positive parabola. And our roots are minus 1 and 4. This horizontal line represents 0, y equals 0. And if we're looking for the values where this function is less than 0, then it's this region here, isn't it? All the values for x which are less than 0, where the function is less than 0 rather. Meaning, we can say for our final answer, x must be less than 4 and x must be greater than negative 1. And this range of values for x, and notice that the question said values of x. Okay. This, guys, gets you the excellence grade here. Your merit. Correct solutions given for the correct expression treated as an equation. So you're treating it as an equation, not an inequation. So these two solutions gets you the merit. And your achieved relationship given for the exponents. So up here is your achieved. Sweet, let's keep going. Question 3C now. Now, how do you pronounce that? Tane. Let's say Tane. No, let's say Tane. Tane and Pete are raising funds for their sports trip. Between them, they need to raise $1,000. There are only 5 weeks until they need the money. Tane gets paid $15 an hour, and Pete gets paid $16 an hour. Okay, between them they work a total of 13 hours each week. What is the average number of hours each of them need to work per week if they are to have exactly the amount of money they need? So again, it's one of these wordy questions where we need to form some equations. First thing we're going to do is use a key. We're going to say T for Tane and P for Pete. And so we could say, looking at it in terms of money, 15T plus 16P equals, they need to raise $1,000, but we're talking on a per week basis, aren't we? So per week, and it says they only have 5 weeks until they need the money, so it's actually 1,000 over 5, which is 200. Okay, that's our first equation. Our second equation is looking at it in terms of hours. You could say T plus P equals 13. That's the total hours each week. Okay, and so we've got our two equations. We can do simultaneous equations here. Again, you could do the elimination method by multiplying this equation by either 15 or 16 and working from there. But the substitution method is again going to be a lot easier. So we could say P equals 13 minus T. And with that, we use this equation. And we say 15T plus 13 minus T equals 200. Okay, so 15T plus, now 16 times 13 is difficult. 16 times 10 is 160. 3 times 16 is 48, so 208 minus 16T equals 200. Collecting like terms and rearranging for T, we're going to say minus T equals minus 8. Therefore, T equals 8. Okay, and we also need P. We can use this equation, T plus P. We could just say, straight away, we could say P equals 13 minus T, which equals 13 minus 8, which equals 5. And with that, I believe we have our excellence here. That is on a per week basis. P equals 5 and T equals 8. Okay, your merit consistently finds the number of hours Pete and Tane worked. Correctly establish the equation in one variable. So here you would get your merit. And achieved identifies equation in terms of P and T for the total amount to be earned per week or in total. So that's the money equation, which is this one. So doing that will get you the achieved. Sweet. Moving on to question 3D, the last question of this paper. If A and B are two consecutive odd numbers where B is greater than A, if C equals B over A minus A over B, give the value of C in terms of A, and explain why this will always be an even number over an odd number. Okay. So we've got this equation, C equals B over A minus A over B. The crux of this question is understanding rules of odd numbers in this case. So if you multiply any number by 2, let's say 2n, then your answer is even. If we said 2n plus 1, then your answer is going to be odd. And because we're working with consecutive odd numbers, the next odd number is going to be 2n plus 3. Okay, that's also odd. Okay. Now, what do we do with that information, I wonder? Well, let's plug it into our equation. Let's say, so B is greater than A, which means this is A and this is B. So let's say 2n plus 3 over 2n plus 1 minus 2n plus 1 over 2n plus 3. Okay, and we've got no choice here but to solve this, or rather simplify this. We have to combine into one fraction. We're going to cross multiply. We're going to multiply that, we're going to multiply that, and we're going to multiply our denominators. So we're going to say 2n plus 3 and 2n plus 3 again, plus 2n plus 1 and 2n plus 1. You could write it in binomial form, which is saying like 2n plus 3 all squared, but it's easier to expand when you write the two sets of brackets, and that's all over 2n plus 1 and 2n plus 3. Okay, so expanding our brackets, we've got 4n squared. The b term is 2ab, which is 12n. 12n plus 9 plus 4n squared plus 4n plus 1. And how much room have we got down here? Okay, that's all over. Expanding these brackets, we've got 4n squared plus 6n plus 2n is plus 8n and plus 3. Collecting like terms, so we've got n squareds, we've got just n's, and we've got single digits. So it's 8n squared plus 16n plus 10, and it's all over 4n squared plus 8n plus 3. And just as I glance at the marking schedule, I see my mistake. I've been adding in the numerator, not subtracting. So let's sort that out. We've got a minus here, it's all in brackets. So we've got 4n squareds cancel, and it's 12n minus 4n, which is 8n. 9 minus 1 is positive 8. Okay. And we can't go any further. Let's just look at what the question's asking us to prove. Explain why this will always be an even number over an odd number. Well, if we look at our final fraction here, looking at the numerator, we've got 8n plus 8, and you will find that if you multiply any number by 8 and then you add 8 to it, that will be even. You could test it. And the numerator, the denominator is 4n squared plus 8n plus 3. Well, the 4n squared is even, 8n is even. You've got an even number so far, but then if you plus 3, that will give you an odd number. Okay. Again, you could test it, and if you had a bit of spare time at the end of this test, you probably should test it. But yes, this is correct, and this gets you the excellence here. Your merit expression for two consecutive odd numbers and substitutes this into the equation. Correct simplification of the fraction, expansion of numerator, simplification of the numerator, all these things gets you the merit. So let's just say merit is, let's say the merit is the expansion. So here is the merit. And your achieved expression. Just writing the expression, so I think here would be the achieved. Okay, and with that, that is the paper. I thank you all for watching. As ever, any questions, comments, chuck them in the comment section below. And I hope you have a good rest of the day. Cheers.